Okay, sorry we started recording without you. This is the summary, so pause and write that down. Then unpause. Okay. So, summarize again to your partner what we just said for the summary of what the process is going to be. Tell them the process of what we're going to do. Okay, so let's look at this first one. This is the easy one, okay? This is the basic one. Find two positive numbers whose product is 192. And the sum of the first plus 3 times the second is a minimum. All right, so we have two positive numbers. What do you want to call them? Okay. So x is the first positive number, y is the second positive number, and we know we want to find two positive numbers whose product is 192. Is that okay so far? Okay. So then it says that the thing that we want to minimize, so you can call this whatever you want. I'm just going to call it m, since that's what we're wanting to minimize or maximize in this. Okay. So this equation that I want to minimize would be what? The sum of the first, so the first is x, and then the sum means to add, plus, let's see, 3 times the second, so 3y is a minimum. So this equation right here is what I want to minimize. But what's not good so far? Two variables. I've got x's and y's. So we have to use other information, right? And we have other information. Which one you want to solve for? Y. Okay, I heard y. Why would you want to solve for y? Okay. Y equals 192 over x. So we're going to go plug that in for y before we minimize. So what's 3 times 192?
576.
500 and what?
76.
Okay. So now that's the equation that we want to minimize. What's one of the other steps that I said that we probably want to think about as we're doing this? A what? A domain. So I know as I'm doing this, I want x to be what? Okay, so x has to be greater than 0, and y is going to have to be greater than 0, because it said they were positive numbers. So as we go and we find our critical values, we know that we can restrict them with those two things. All right, so now we can use our first or second derivative test, but regardless, we're going to have to find at least the first derivative. Okay, so let's find our first derivative. got 1 and then minus 576 over x squared. And I'm going to go ahead and write that with a common denominator. So what are my critical numbers? 0 from the denominator, where f prime or m prime is undefined, plus or minus the square root of 576. How to say square root? 24! Yeah, that is. Okay. So that's where we got that from. Alright, but within my feasible domain, do I have to check all of these? Just the positives. So do you want to set up a number line for the first derivative test, or do you want to find the second derivative and plug in the value for the second derivative test? Second derivative test. Alrighty. So we'll show both ways, okay? If we did the second derivative test, what is that second derivative going to be? Now it's going to be a positive 576 times 2 over x cubed, right? In double time. Well, yeah, that's just... Right? So that's not too bad. Right? I mean, I didn't do the 2 times 576 in my that's the hard part. That's a little math thing. Alright, so let's see. If I plug in 24, what do I get out? A positive or a negative? That's all we're worried about, which means that 24 is going to be a what? Min, because you're concave up. Show me concave up. You have a max or min? Min. Okay, so this is a relative min. Are we trying to find a relative min or a relative max? Okay, we are trying to find a relative min, so this makes us happy. If I had done the first derivative test, then now I'm going to set up my number line with 24, and we're going to plug in values before and after into the first derivative. So like 1, if I plug 1 in, that's definitely going to be negative, so m is decreasing. If I plugged in 25 or something, I'm going to get out a positive, so that's going to be increasing. So that is a relative min. So either one of these tests would be fine, but you have to check that it is a relative min. Now what? Can you finish the problem? Okay, finish it. And Would you get 24 and 8? And there's really no label on these, right? Not a lot of interpretation. Questions? Next. Suppose production cost is given by this equation, where X represents thousands of units produced. Is there a production level that minimizes average cost, which is the C equals C of X over X? And if so, what is it? So, can you write your equation? Yes, do it. So are you minimizing C of X or C? C. C. How'd you do on your equation? Okay. So you do the next step. It's already in terms of one variable, right? What's your feasible domain for X? 0 to what? Huh? Positive. Alright, so X has to be greater than 0. Keep going. You get a critical number of 3. Okay, keep going. You're trying to check that 3 is a relative what? Then you can use the first or the second derivative test. I don't care. You do not need both. Second derivative is super easy to find here. But first derivative test isn't that bad either. We're recording notes too, so anything in this I'll put on mutuality. Okay, so regardless of which way you decided, did you get it to be a relative min? Alright. Now keep going. thousands of units produced. This is a production level that minimizes average cost. So it's going to occur, so yes, it occurs when x equals 3, right? Which is actually 3,000 because it said 1,000. So what does that give us? Yeah, 6,000. So the minimum average cost is 6,000. Would that be something important to know in business?
Yeah.
Oh, gotcha. Yes. Yes. Yes, yes, yes. And then the cost is. Okay, 2 more. We can do this. We can do this. 2 more. Oh, I got my boots on for this next one. That's a good sign. You might want to read this one in the fun accent. Come on, guys. Give us the fun accent. No, come on. It's a right answer. Come on, Matt. Just try. Do your best. Okay. Okay, Matt's going to do his best. Here he goes.
Rancher has 200 feet of fences, which can enclose 2 adjacent corrals. But the dimensions should each corral be so that the enclosed area can maximum.
Yeah, I like that. I like it. I don't know if it will pick it up. But... Okay, you want to draw a picture to help you on this, or what do you want to do? Okay, so let's draw a picture. Okay, how do you want to do this? Length and width. So, what's this guy? The length? And this would be the width? Yeah? Okay, keep going.
2L plus 3W equals 200.
Uh-huh. You know where he got that from? Where, Danny?
From adding up the sides.
For the...
Perimeter.
Oh, you're so hot. Okay. So 200 is going to equal 3W plus 2L. So that's how much fencing he has to enclose everything. Is that an equation that I'm wanting to maximize or minimize? Is that the equation? No, what equation am I wanting to maximize here? An area. So that's just extra information for me, probably to help with solving for a variable, right? So let's write our area problem here now. And I could see a couple different ways that you could start this one.
L times W.
Okay, so if we did L times W, then we're finding both of them, right? So this one says each corral.
One corral L times 1/3 W.
Well, what's the area of just one corral?
W times half.
Oh, okay. So if it was me, that's how I would start it. Is I would say that the area formula that I'm trying to maximize is just one corral, which would be half of the L times W. Now you know what you already need to do. Yes? Finish this problem. Finish it. So work together. You got it. When you have an answer, let me know.
No, because like we put here square, the middle section doesn't affect the other W. But so so it's like inherited and
Do you guys solve for L or W? W? So whichever one you solve for. I don't care. Pick one, plug it in. I'm going to use the solving for the L so that my 1/2 and my 2 will cancel. Oh. Oh my gosh.
I was going to say, but I think you got math.
Whoops.
There is the
Oh,
same.
Mr. Rose. I just wanted to see if you guys were paying attention. I was. Gosh. 50. I don't know what I was thinking. we're checking that this still is a max. Again, that second derivative actually would probably be a quicker way, but whatever. I already do my number line. I do see that it is a relative max. If I asked you to prove that it is a relative max, is that enough information? No, what would you have to say? It's a relative max because A prime goes from positive to negative at W equals 100 thirds. So we know our W. So how many of you guys would say the answer is 100 thirds, is it feet? Feet by 50 feet. No. Chandler's saying no. 50 feet is what? That whole length for both of them. So just one of the corrals would have to be a length of 25. So you might make a little note in your notes where that 25 came from. I'm not sure that you'll remember it. We did solve L, but L is the length of both of them together. Bummer. Okay, we'll have to wait and do the very last example next class. It's really cool. It's fun. And then go ahead and start on your homework and everything. You're not quizzed on it until Tuesday. Okay? So go ahead and get started. Maybe give us tonight on. Oh yeah, but we'll finish that up. Which I will take over. We stop at 6:30.